we're going to graph the quadratics using standard form. So let's remind ourselves what the standard form of a quadratic equation looks like. That's y equals ax squared plus bx plus c. Now your y can also be f of x, g of x. It can be written in function notation also. So just know that these are interchangeable, but the key is ax squared plus bx plus c. Now, just a recap of what we did last section. Find the axis of symmetry. Remember that the OAS. In the axis of symmetry, the x value is the opposite of b over 2a. So the x value, once you find the x value, plug it into the equation to solve for y. So you're going to find your vertex xy. Put the vertex in the middle row of the table. So what we're going to do is that we're giving ideas for here. So this is now going to be the table. I like to put it in the middle row of the table. If there's 5, then your vertex, we're going to put right here in the middle one. So we're going to explain what that means. We are then going to connect the points to form a smooth parabola. So remember, a quadratic forms a parabola. And I'll show you how to pick other points besides your vertex points. Okay. Now, we're also going to talk about what we call about decreasing and increasing. It's like when you throw a ball to the ground, like a bouncy ball or basketball, anything. I know you can go straight up and down. Oh, let's do the diving method, or the diving example. If we dove in, we're decreasing, we're going down into the water and then hit the bottom or somehow turn, either not hit the bottom if it's too deep, or if it's the ocean, you're not going to hit the bottom, but you're going to turn and come back up, you're increasing. Okay, so we're going to talk about a decreasing and increasing and when that happens. So let's practice this. We're going to graph the quadratic equation using a table where I identify the AOS, the axis of symmetry, the Y-intercept, the vertex, and then we're going to do the domain and range. So we need to first find the vertex. We got to first of all figure out, where is it going to make that change? Where's the turning point? But first let's look at our equation. Our equation says f of x equals x squared. That's it. There's no x and there's no c term. There's no b term, there's no c term. So now the x squared means this is 1. So your a is 1, your b is 0, your c is 0. So this is actually what we're going to be calling a parent function, meaning this is going to be the very basic parabola possible. Okay, so what we're going to do there, we got to find the axis of symmetry first. Okay, so the OAS. Now remember, it's x equals the opposite of b over 2a. So opposite of b, well, that's 0 over 2 times 1. Well, negative opposite is 0. You can't have that, but that's 0 over 2, which is 0. So when x equals 0, we're going to now find y. When x is 0, so you're taking f of x equals 0 squared, which is going to be 0. So our AOS, axis of symmetry, and our vertex, actually our vertex is going to be 0, 0. Meaning it's going to be here where it's going to change turning point. We're going to determine if it's going up or if it's going down. Now remember, look at your A term. Your A term's positive. So if it's positive, it opens up. Okay, so here's what I would do. Since I look at my coordinate grid, I don't want to make tons of like really high numbers. So if I'm just given 5 numbers here, on this one, I'm going to do -2, -1, 0, 1, and 2. I'm just going to use those 5 points. Now I have to find my y value. The reason I'm using those 5 points is because it stays close to the y-axis. I don't have to graph way out here or way up here. Now, -2 squared. Careful. When you take -2 squared, make sure you have parentheses, because -2 times -2 is a positive 4. So your y is a 4. -1 squared. Okay, -1 squared is 1. 0, 0. 1 squared. Well, 1 squared is 1. 2 squared is 4. Do you notice something here? Look at the table. If it goes in a -2, you come out 4. It goes in a +2, it comes out 4. These, notice they just kind of repeat. And this is what's symbolizing it's a quadratic. It's going to be the same on both sides. So let's graph this. So we're going to have 0, 0. Where's our vertex? 0, so 0, 0 is our vertex. Now, negative 2, 4, negative 2, 4, negative 1, 1, positive 1, 1, and 2, 4. Now, we're going to smooth this out. Good luck. Okay, I'm going to smooth this out. And we're just going to try to make a parabol. Oh gosh, sometimes my drawing is terrible. That is terrible. But it should be a nice curved, that looks like a smashed in view or something. But that should be a nice curve. I should do smaller sketches. All these people who draw nicely, anyway, who cares? Okay, now it opens up. So do we have a minimum or a maximum? We have a minimum. We have the lowest point here. Now, axis of symmetry. Remember, the axis of symmetry is right here. Where does it go in the middle? And that's going to be 0, because that is the turning point of when it changes locations. It's the turning of where it's changing. Now, domain. Remember, domain is your x value. And we were able to pick any number. Like, you didn't have to pick these numbers. You could have picked all real numbers. And remember that symbol that are like that. Okay, so that's all real numbers. Now, range. Here's where you got to be careful. The range, remember, the range are your y values. So I'm capped right here, but I'm not capped up there. We can keep going forever. So the lowest value on your y values have to be greater than or equal to 0. So the lowest point is here. You can't go any lower, but I can keep going higher. And my diving example doesn't make any sense because you can't like float in the air, at least not on Earth. Now, your y-intercept is when x is 0, your y-intercept is going to be this one. So when your x is 0, so your y-intercept is 0, it crossed the y-axis at 0. Again, if this is going too fast, just pause it and stop and think about it. Now, these are new terms, increasing and decreasing. Notice here, g of x, that's your y value. The y value is increasing. The y value increases right here when x is greater than 0. At this turning point, at this axis of symmetry, it changes locations, or changes, not locations, direction. So when the y values start to increase as the x is increasing greater than 0. Now, the y values are decreasing when the x values are less than 0. That's, to me, is sometimes hard, because to me, this looks like it's, even though the arrow is going up, the y values are decreasing as the x is less than 0. It's decreasing, and then it's going back up. It's like bouncing a ball. You're dropping it, and it hits the ground, and it comes back up. Okay? I know that can be a little confusing. Okay, so let's try this one. First, identify your A term, your B term, and your C term. So your A is -1, your B is -8, and your C is -15, or 17. I don't know why I said 15. -17. Okay, so let's do the AOS, the vertex. The vertex, 1, 2, 3. Your vertex is going to be right here. I like it in the center. It just makes it easier to, I don't know. I kind of like it in the center. But this is your vertex. Your vertex, opposite of B over 2A. So the opposite of 8 over 2 times -1. -8 over -2. X is going to equal 4. Now, once x equals 4, plug that. Should be +4. I'm looking at the opposite. Oh, shoot. God. Oh, Detlefson. The opposite of -8. That's my problem. Dang it. This is why I do like live teaching. Opposite of -8. That's going to be negative. No, that's going to be a positive. That's going to be an 8 divided by -2. That's going to be a -4. Dang it, Detlefson. Get your act together, lady. All right. -4. So -4. Now, -4, we got to be careful. The x is -4. The -4 is x. So -4 squared is +16, but we have the opposite here. So we have opposite of a -4, -8 times -2, and then -17. -16 plus 32 is +16 minus 17. That's going to be a -1. So -4, -1. That should be our vertex. -4, -1. Axis of symmetry is going to be at -4. That's what we just found here. This is what this is. It's where is it? The vertex is where it's changing location. Now, since it's a negative a term, this is going to open down. Now, we'll come back to that, and we'll come back to these. Oh, the y-intercept. On this one, I'm not going to do the y-intercept because if I put in 0 for these, I have a y-intercept of a -17. So we can have a -17, but there's no way I'm going to graph that because this only goes to -10. I'm not going to graph the y-intercept. We won't see it on this graph. Okay, since our x value, our vertex is -4, our AOS is -4, I'm just going to go back one of each of these. -2, -3, -4. Let's do -5, -6. We're going to actually, since that's the vertex, I'm going to do some on one side of it and some on the other side of it. Here's what we have to then calculate. You're going to take -2 in for x. Be careful. So -2 squared. So this is going to be opposite -2 squared minus 8 times -2 minus 17. -2 squared is 4, but we have this negative here. So we have a -4 plus 16 minus 17. -4 plus 16 is 12 minus 17, -5. Okay, -5. Then -3 in for x, opposite of -3 squared, minus 8 times -3 minus 17. The opposite of 9 plus 24 minus 17. -9 plus 24, okay, so -9. I don't know why I went blank. I had to do a calculator. I don't know why I did that. -2. So -2. Now, well, here's the thing too, you guys. Since it's a quadratic and these are going up by or going down by 1, this is going to repeat. This is going to be -5, -2, -1. Then it's going to go back up, -2, -5. Just to let you know, if you have this increment of like 1 or a common change, rate of change here, that's going to be, is just going to mirror each other. So just to look at, so we're going to save a little time in calculating. So let's graph it now. The vertex, -4, -1, -4, -1, -2, -5, -3, -2. Then this is, here's your line of symmetry. So it should just mirror -5, -2, -6, -5. Okay, and then try to sketch. Oh, that's not too bad. So that's what it would look like. So you're going to have a maximum point. You have a maximum point. Domain, we could pick any. So this is going to be all real numbers. We can pick any value for the x. Now the range, notice the range, I'm going to do a different color. The range stops. The y values are limited right there. So y has to be less than or equal to, what is that, -2? Less than or equal to -2. The y-intercept's 4. Or y-intercept's -17, but we're not going to see it. It's going to cross. If this kept going, it'd cross down here somewhere, the -17. Now, g of x, that means that's the y value. The y value is increasing. The y value is increasing as the x is less than -4. As the x is less than -4, the y values are increasing. Now this I think this is confusing. It's kind of easy, but then confusing at the same time. It's decreasing. The y values are decreasing greater than -4.